Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the 11th question from the preliminary exam which was written in the year of 2023 at St. Mary's School in Waverley. Please do expect a total number of 12 videos since the question paper had 12 questions in total. And that simply means each and every question will have its own video. And please guys, do take these seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are told that a graph of a cubic function f of x is drawn on the axis below. The point M lies on the graph of f of x and the line y is equal to negative 2x plus c is a tangent to the curve at point W. Okay, first question, they just want us to show that A is 2 and B is equal to 30. Both A and B guys, A is the coefficient of x cubed and then B is just the coefficient of x. Remember that the equation of our graph f of x is given to us as ax cubed minus 14x squared plus bx minus 18. Are you together? Minus 18. And then we are told that guys, M lies on the graph of f of x, and then we are told that y is a tangent to f of x at point W. We are looking for two unknowns. That means guys, we must solve simultaneously. Nah? Okay. The function value is 6 if and only if the x value is just equal to 4. If and only if the x value is equal to 4 plus bx, that's 4 minus 18. So therefore we'll have 6 is equal to 4 to the power 3, that's 64a minus 14 multiplied by 4 squared. 14 multiplied by 4 squared is just 224 plus 4b minus 18. So therefore on the left hand side we'll end up having positive 224 plus 18 plus 6 again. That's 224 plus 18 plus 6. On the left hand side guys, we'll end up having 248 is just equal to 64a plus 4b, right? I can divide each and every term by 4. 248 divided by 4, this will just give me 62. And then 64 divided by 4 is equal to 16. That's just b. Therefore, b is simply equal to 62 minus 16a. This is just equation 1. Are you together? Remember that guys, I was also told about the tangent. And I know that guys, the derivative of a curve is equal to the gradient of a tangent at a specific point. So if I can find my derivative, if I can find f prime of x, which would be equal to 3ax squared minus 28x plus b. This is my derivative, right? And I know that guys, the derivative is just equal to the gradient of a tangent at a specific point. So I now know that since the point of contact between the tangent and the graph is 2 there, so the derivative of the curve when x is equal to 2 will just be equal to the gradient of a tangent. Right, together. So therefore 3a, if I substitute 2 whenever I come across x, that means on the right hand side of the equal sign I must have a negative 2, because the derivative is equal to negative 2 if and only if x is equal to 2. Are you together? So I'll simply have 4 times a, that's just 12a, minus 28 times 2, that's 56, plus b is equal to a negative 2, right? So therefore b is just equal to negative 2 plus 56. Negative 2 plus 56 will just give us a positive 54 minus 12a. This is my second equation. Now I have two equations, guys. So I can therefore conclude that equation 1 is equal to equation 2. Why is that the case? Because both of the equations are equal to b. So I'll end up having 62 minus 16a being equal to 45 minus 12a. If I group the like terms, guys, I'll have 62 minus 45 is equal to 12a, is equal to negative 12a rather, plus 16a. Then 62 minus 45, 62 minus 45, what do we get? Where did I find the 45? Oh, it was supposed to be 54. Excuse me, guys. Hey. Please remember that, guys. I'll take this thing to the other side. So it's negative 2 plus 56. Because whenever it jumps an equal sign, it becomes positive, right? So it's 54, not 45. It's 54. It's 54, guys, nah? Not 45. That's 54, and I have 54 as well. So 62 minus 54 will simply be equal to 8, and then on the other side I'll have 4a. Then if I divide both sides by 4, I'll therefore conclude that a is equal to 2. Are you together? And then after finding the value of a, I can simply go and find the value of b. b will simply be equal to 62 minus 16 times a. A is just equal to 2, right? So if I get 30, that means I am correct. 62 minus 16 times 2, this is equal to 30. That's how, guys, you're supposed to show that the value of a is 2 and the value of b is 30. Né? Firstly, guys, deal with this point over here. We are told that y is equal to 6 when x is 4. Do substitute that, you'll end up having two unknowns, that is a and b. And then we are told that the tangent to the curve has a gradient of negative 2 whenever x is equal to 2. Remember that, guys, the derivative of a curve is always equal to the gradient of a tangent at a specific point. Are you together? So that simply means the derivative of the curve when x is equal to 2 will be equal to negative 2x. Then we'll have two unknowns, then solve for a and b. That's how, guys, we could have done it now. Okay, and then now you're supposed to determine the values of x where the tangent has a horizontal line. The tangent, guys, is only a horizontal line at the turning point of the curve. So basically they want us to find the x values at turning point. I know that f of x is equal to 2x cubed minus 14 x squared plus 30 x minus 18, right? So my derivative is equal to 6 x squared minus 28 x plus 30. Why am I finding the derivative, guys? Because at turning point, I know that the gradient of my tangent is equal to 0. Why is the gradient of a tangent equal to 0? Because I have a horizontal line. A gradient of a horizontal line is forever 0. So I'll simply say f prime of x is just equal to 0, and therefore 6x squared minus 28x plus 30 is equal to 0. You can divide each and every term over there by 3. You'll end up having 2x squared minus what is 28 divided by 3? 28 is not divisible by 3. Okay, let's just find factors over here. I'm looking for the factors that will give me 28 whenever I add them. Nah? So I'll have 6. Let's try 3 and 2, and then let's also try 5 and 6. this is 15 and that is 12. 15 plus 12 is 27. Okay, let's change around and check if we do it like this. Yeah, so our brackets, guys, will simply be 3x and 5, 2x and 6. The sign there is plus, so our brackets will have the same sign. I'll have minus and minus, and hence x will just be equal to 5 over 3, or x is just equal to 6 over 2, which is just 3. So these are the solutions, guys, whenever these are the solutions whenever, guys, the thingy, the tangent has is a horizontal line. Our tangent will be a horizontal line over here at the turning point and over there as well. Okay, and then now, guys, they want us to find the values of x, determine the values of k for which f of x will have one root. Okay, if guys, f of x is equal to k, k is just a straight line. If ever, guys, I have a graph above by turning point, that graph will only intersect the function only once. And if ever I have my graph below the turning point, that graph will just intersect my function only once as well, right? So that means k should be greater than the maximum, or k should be less than the minimum. Are you together, guys? So let's go find both the maximum and the minimum. Okay, for the maximum, I'll simply substitute 5 over 3 on the original graph of f of x for me to find the maximum value, plus 30 times 5 over 3 minus 18. 2 multiplied by 5 over 3 cubed minus 14 times 5 over 3 squared plus 30 times 5 over 3 minus 18. So the answer is just 64 over 27. Are you together? This is our maximum value. Our minimum value, guys, f of 3 will simply give us 0. So maximum is equal to 64 over 27, and then minimum is just equal to 0. Remember that, guys, our graph looks like this. Our graph looks like this. I said we'll only have one root if k is above the maximum or k is below the minimum, right? So therefore k is greater than 64 over 27, or k is just less than 0. That's how, guys, you're supposed to tackle that question over there. And then we are told that h is a cubic function that has the following properties. We are told that h of 1 is equal to 0. Okay, so this guy is our x-intercept. Are you together? And then h prime of 1 and h prime of 7 are both equal to 0. These two are the x value at turning point. Are you together? One of them is the maximum, another one is the minimum, and then over there we are given the y-intercept. Why do I say it's the y-intercept? Because x is only 0 on the y-axis. This is the x-axis. This is the x-intercept rather, because y is only 0 on the x-axis, and then the derivative is only equal to 0, guys, at the turning point. Okay, and then now we are told that the second derivative is less than 0 when x is 7. Okay, that means, guys, this guy over here is our maximum. Are you together? That's how, guys, you check the nature of your stationary point, whether is it a maximum or minimum, right? We use second derivative test. Are we together? We'll simply use the second derivative test. That simply means if ever the x value turning point will give you a negative answer, that means that x value belongs at the maximum. But if it gave us a positive answer, we would have concluded that it belongs at the minimum value. So basically, guys, our graph is supposed to look like this. Our graph is supposed to look like this. Are you together? We'll simply have a 9 over there. Our graph should turn on the x-axis. Why? Because x is equal to 1 is both an x-intercept and a turning point. That's why our graph should turn on the x-axis. And then over here we have x is equal to 7. We are not given anything about the other x-intercept. So our graph, guys, was just going to be drawn like this. Nah? Our graph was just going to be drawn like this. But let's answer the questions. Firstly, they want us to determine the value of c such that the second derivative of c is equal to 0. The second derivative of c is equal to 0. That means, guys, c belongs at the point of inflection. Are you together? Because you can only find the second derivative to be equal to 0 at the point of inflection. How do we find the point of inflection? If, guys, I have my two x values at turning point, I can simply say that c is just the average of these two x values. That's just 1 plus 7 all over 2. That's equal to 4. So therefore c is just equal to 4, and hence h double prime of 4 will be equal to 0. And then now they want us to sketch the graph, guys. On the axis provided, draw a rough sketch of h of x indicating the y-intercept and the x coordinates of the turning points and the point of inflection. Our graph, as we just said, guys, it will be just like this. It should turn over here when x is equal to 1. The x value turning point is equal to 7, and then the point of inflection over there will have an x value of 4. And then what else do you know? The y-intercept was given to us as 9. So that's how, guys, we're supposed to tackle this question over there. So please, guys, do stay tuned and wait for more videos. Thank you.